Good morning, everyone. Today we are going to begin Unit 1 Cross Validation from the course AD 3501 Deep Learning. Cross validation is very important concept used in machine learning to check how well our model performs on unseen data. So first is cross-validation overview. The cross-validation is a technique used to evaluate how well the model will be generalized to new or unseen data instead of depending on a single train or test split. We divide the data into several subsets. The model is trained on one subset and tested on another set. So this helps us avoid overfitting and gives a more reliable estimate of performances. So what is the basic steps in cross validation? The cross validation is generally involves four main steps. First, we reserve a part of our data set as a validation set. Second, then the model is trained on the remaining training data. After training, we test it on the validation set. Finally, based on the performance, we'll adjust the model and repeat if needed. This ensures our model is evaluated properly before deployment. So next, the methods of cross validation. There are several types of cross validation methods available. The most common one is validation set approach, leave p out and leave 1 out, k-fold, stratified k-fold, and hold out method. So each method has its own advantages based on the data type size and its problem type. Next is validation set approach. In validation set approach, we split the data set into two parts, usually 50% of training and 50% of for testing or for validation. This model is trained on one half and it is evaluated on the other. However, the major drawback is that we lost 50% of our training data, so which can lead to underfitting, especially when the data set is very small. Next is leave p-cut cross validation. In leave p-cut cross validation, we leave out p samples and validation and train on the remaining samples. This process is repeated for all combinations and the performance is averaged. So though it's high accurate, it becomes computationally expensive when we are using large data set. Next is leave one cut cross validation. This is a special case of leave p out where p is equal to 1. That means every single data point becomes a test sample once and the remaining point forms a training set. The advantage is it uses the maximum data for training and gives a very unbiased result. However, it requires a lot of computational and it can be slow. Next is k-fold cross validation. We divide the data set into k equal parts or folds. Each fold is used once at the test set and the remaining k folds are used for training. For example, in 5-fold CV, the process repeats 5 times. This method is easy to understand and gives a stable and less biased results compared to the train and test split. Next is stratified k-fold cross validation. It's mainly used in imbalanced data sets. It ensures that each fold has same class distribution and the overall data sets. This is extremely useful in the field of medical diagnosis where the certain classes are rare. Next is holdout method. The holdout method is the simplest cross validation approach. We randomly split the data set into training set and testing set. However, since it relies on only one split, it has a high variance and may give a misleading performance results. Next is cross validation versus training and testing split. The training and testing split uses only one division of data like 70:30 or 80:20. This may lead to a biased and unstable result. So the cross validation on the other hand uses multiple splits of data and averages the results. So it ensures every data point is used for both training and testing, which makes it more reliable. So what is the limitation of cross validation? Even though cross validation is powerful, it has some limitations. The first one is it may give inconsistent result if the data set quality is poor, and if the data set keeps on changing over time, the result may vary. And it's computationally intensive for larger data sets, so we must choose a right method depending on the data. And what is the application of cross validation? The cross validation is widely used in real world machine learning applications, comparing different machine learning models, medical research, meta analysis, statistical model validation. So overall, it's an essential tool to build the reliable and accurate predictive models. Okay, thank you for listening.